Okay. All right. Well, let's get started. Today's webinar is focused on the importance of communications between designers, contractors, and customers for every geothermal project. And the presentation today is sponsored by Ground Loop Design Software, and it's the fifth in a series of presentations regarding geothermal topics for our commercial design audience. For viewing any of the previous webinars, we do have them posted in to recording this one if you need to look back at it later. Visit the groundloopdesign.com website and click on webinars. We've got a list of tutorials as well as the last 4 presentations that have been done on a monthly basis. You know, there's a lot of good training out there available for professionals, and we're glad that you're sitting in on this. We'd encourage each of you also to check out the types of classes that are offered for the tools you use, whether it's GLB or trace or HAP on the load side, or consider the DGD track from IGSPA. Everything you do to help yourself and help the industry is appreciated. A little bit about our presenter today. Terry has been involved in the ground source pump industry since about 1993. He's an accredited installer through IGSPA. He spent over 15 years previously as a geologist in the petroleum industry, starting really a second career in mechanical trades. His residential and commercial work includes heat load analysis, loop design, thermal conductivity training, field installations, and I guess you can just say he's done it all. He's designed and consulted, installed thousands of tons of heat ton capacity throughout the U.S., Canada, and Asia, and over 500 contractors and engineers in the IGSPA and field training classes. He's one of the practicing change designers in Colorado. He's factory certified climate and a member of the Rocky Mountain Trade Group. And with that, I'm going to Terry.
Yes,
welcome.
Appreciate it. I'm not sure of everyone's background that's going to be reviewing today, but we're going to try and focus for simplicity due to the limited time frame on just vertical loops, but a lot of what you're going to see today is also applicable to doing a horizontal loop, whether it's a trench or pit system or a surface water heat exchanger. So with that, we'll get moving. Assuming I can get, there we go, second slide. Hope y'all can see my nice ugly thumb there. That's not my thumb, but Ed Lorenz shared that thumb with me. Just trying to make a point here, and it goes back to Ground Loop Design's motto, ground source heat pump systems that work by design, not by chance. It's my opinion and a lot of others that our industry would be a lot more robust if we didn't have a lot of systems that were designed by assumption. So with that, would like to just make the point that what we find that is a big help on any project is a preliminary assessment. It's not just looking at the site, but before you actually get going is understand the building requirements first. That is, before you start playing with your loop design software, you have to understand your loads and your heat pump schedule first. Then you have to look at your site considerations, and then you can use GLD or any other appropriate loop design software to try and rough out the size and scope of your loop field. And we're going to take this into the communication part now, where we find that a lot of folks can get a lot of benefit at this early stage by talking with experienced loop installation contractors. For one thing, it's nice to know if you have a depth that is very problematic, or, for example, you may want to go deeper because you have a lot of loose overburden that requires casing or whatnot. So if you're going to have to case the upper parts of the holes, it might make sense to have fewer holes and go deeper. So there's a lot of common sense things you can put into your design process at an early stage just by talking with the people that actually drill the holes. The other thing is understanding what contractors have, what kind of assets. If they don't have a big enough drill rig for deeper work, or they can't do shallow surface casing, that needs to come into your evaluation thought process as you go through your design. And just to make a point, knowing the right, having the right tools for the jobs can make a difference. That big device on the right of the screen is for stripping overburden for coal mining in Germany. So it's a pretty big unit. Okay, pre-design. Now you're going to take what you've learned through your preliminary assessment of the building loads, the heat pump schedule, where you think the size of your loop field might land, and then consider any limitations of the geology, your contractor assets. You might even have issues with local or state regulatory agencies limiting the size of pipe you can use or the depths you can go to. There are some states here in the U.S. that have those limitations. I don't think that's such an issue in most countries or outside the U.S., but our states can be very strange and have different sets of laws. The other thing to consider is where can you go and not go on the site. That's why it's important to be talking with the rest of the design and construction team to understand if there's a civil or utility issue that you've got to avoid. Essentially, you need to know the size of the sandbox you're going to be playing with. What I like to do during pre-design is I'll come up with a general site plan on a site plan drawing, and I'll lay out the limits of the worst case size of the ground loop, what it might be, and then I'll fire that off to the rest of the construction and design team and ask for any red flags that, you know, hey guys, are we going to run into this? Something that you can't tolerate or whatever. And it gives them a chance to comment early on. Once you start getting into further into the pre-design, now's the time, if you're going to run a TC test, to use your pre-design effort with your loop design software to determine your thermal conductivity test parameters. We never go out and run a TC test if we can help it without knowing the restrictions on the site, the loads, and run a preliminary design and set a test hole specification and location that's compatible with the least to the largest size of the ground loop. Remember, a 300-foot test is not going to give you the same thermal conductivity values as a 500-foot test. So you need to pick a test depth and pipe size that you're going to stick with through the rest of the design. So it's very important to go through that process early. A lot of times we run into projects where a project manager will say, "Oh gosh, DC test, drill it." They lose touch that this is a key part of the mechanical system, and I'm sure you guys have seen it too, where people run out and do a TC test without even knowing the size of the building, whether or not they can integrate that loop into the test or into the final operating ground loop field or not. We'll even take it so far where we'll actually write a written specification for our test. And I think I've got a link here. I hope everyone can see. I've got a Word or a PDF of a thermal conductivity test specification on the screen. I hope everyone can see that. But we have a brief narrative of the scope of what we're trying to do. We'll make a recommendation on minimum or maximum bore diameter. completed bore depth, in this case a 605-foot hole below grade. Because we're thinking ahead, we want a certain length of tail on that test loop, because we are going to integrate that into the final loop design. So we want to have a little bit of extra pipe on the surface to play with. For standard specifications for your polyethylene pipe, and everything else looks like it's right out of a Division 23 specification. So then we'll select the test hole location that works with the least to the largest size, and then we want to run that. We want to be able to use that test hole later and not waste it. So when you get your test done, you want to talk, or before you get it done, you want to be visiting with whoever's going to be running that test and verify they understand the parameters, they understand the location, and the importance of why you sited it there. Another thing that we see that's kind of loose sometimes with some people that do testing, if we'll spec like a 400-foot test and they'll get down to like 360 or 370 feet because of drilling issues and not tell anyone. And I have a problem with that because we may be needing every linear foot of borehole we can get on a limited urban site, for example. So I make a very, very strong point with the drillers we use that if we say 405 foot, we mean 405 foot to get that U-bend into. And also we like to make sure that they're using the right power settings on their data log. Just an example, this is an example of a good TC test. We have a nice consistent slope, which is that slope is actual, that ratio average is our actual TC value. And you can see the power input is very consistent. So this is good stuff. This is a very bad test. In fact, we had to tell the client we couldn't use the data because it couldn't be relied upon. Power was all over the map. They used a little Briggs & Stratton 3 horsepower generator. You can see where they ran out of gas a couple of times early on. Had other problems. It was a mess. This was not a good. The client was trying to cheap everything out. We don't even understand why he was trying to consider ground source. It was he just wanted cheap, cheap, cheap. Anyways, he got cheap. Okay, so when we get into the design part of the project, we want to take all of your TC test data, knowledge of the local geology, where there might be limitations, your contractor capabilities, limitations from the design construction team that they might have imposed upon you, and get down to final field layout. So what you're going to look at is reconfigure your design for the optimum number of bores. You want to look at your headering schedule. That is how many bores per header pair, how you're going to fit to the available area. And it's going to be a bit of a team effort. You're going to be bringing in input from all those involved with the civil, structural, architect, all the above. And make sure that you keep that test hole integrated into your final loop field layout. Another key thing is on your reducing manifold schedule, you always have to keep in mind how easy can you make it to remove the air out of the system. GLD has a nice module for helping you do that. And what I like to do is do a preliminary purging calculation to get that 2 foot per second flow velocity determined. For example, 1.25 inch DR11 circuit pipe needs 9.1 GPM to get 2 foot velocity. Well, if you've got 10 holes on a header pair, that's going to be 91 GPM. Then you calculate the pressure drop, And I like to early on make sure that the contractor, whether it's the driller or the mechanical side, has enough purge pump capacity to deal with that. Sometimes we have to tell them that's the way it's going to be, they've got to get it, or other times I might alter the design slightly because the guy doesn't have enough power and he's the only game in town. For whatever reason, if we can accommodate them, we will. If not, they're going to have to step up to the plate. At this point through your design, you should be finalizing your Division 23 specifications and getting that out early as possible for the contractor teams to review. And this is going to look something like this. This is for a project in Seabrook, Colorado on the Eastern Plains. And I don't know how many of you guys deal with the Division 23 specs, but usually if you're designing a loop field for a commercial project, you're going to have to produce something along these lines. And this is going to be very important because this is the roadmap essentially for the loop installation contractor and everyone associated with the ground loop on what's expected and what they have to provide. So it gives all the details for product minimum standards, procedures, and specifications. And it takes away any doubt if someone tries to slip in something that's you know, like bringing in PVC pipe instead of HDPE, you know, something extreme like that. I've even got a point right here where I want the warranty on the pipe to be non-prorated. I only want product in there where the manufacturer believes that the, you know, he's got enough confidence in his product to warrant it for 50 years and not have a prorate NICU clause in the warranty. You know, it's rare that we ever have a problem with the ground loop, but I like to get a very solid warranty on these things. Thermally enhanced grout. In this case, we didn't need it, so I just line item rejected the requirements for the grout testing. We take it to a little bit more detail under execution. I'll even have a brief description of the ground loop, in this case 50 holes, 400 foot deep, minimum with spacing requirements, header pipe size, that sort of thing. I even get into a little more detail with the purging sequence and fusion work. I even outline what we expect, not just the that stupid thing. I hope that didn't bother anyone. Pop-ups. Anyways, we don't rely on just saying check with ICSPA standards. We will put in the actual temperatures that we expect on the fusion equipment. Warranties, of course. In this case, for 10 circuits per header pair, I've even got the minimum purge rate and the minimum pressure drop I've calculated they have to get on that. And I've even got a note down here. In any case, the minimum flow rate per header pair is to be met or exceeded for air removal, regardless what the header line length turns out to be. So anyways, that gives you an idea of a little bit more of a detailed Division 23 specification. Very important in communication. Another thing that I'm very big on is site plan nomenclature. I like to number each borehole by like header pair A, 1 through 10, that sort of thing. That way, if you have a problem during installation, gets everyone on the same page if the driller's got a problem on a specific hole. And here's an example. For example, up here in the upper left part of the screen, that's the test hole location that's integrated into the final field that's going to be under the playing field of this school. And as you can see, we've got E1 through E10 for header pair E, and A1 through A10. And I usually start out with the A header set, that being closest to the mechanical room, and then going to the higher letter grade, just to try and standardize it. Okay, budget considerations. One of the things we see a lot, and you can talk to your driller about this, again, this goes back to communications, is some drillers charge a premium for thermally enhanced grout, others not so much. What we found in the markets that we design in, that if you're going to go to a 0.90 thermal conductivity grout or even higher at 1.10, you're going to add anywhere from 50 cents to $1.50 per foot to the installed cost. So that kind of communication and feedback is really important, because you can use software such as GLD to test, do you even need thermally enhanced grout? And to test that, if I say I don't want a maximum entering water temperature more than 85 degrees, see if the load's cooling dominant, I'll take that the heating load and run the loop model without hitting offset heat load to see if the a pure cooling heat rejected loop will handle it with or without the thermally enhanced grout. Another thing that I'll do is I found that I can reduce the need for thermally enhanced grout by increasing spacing. A lot of guys just say 20-foot spacing and we'll call it good. I found by going to 25 and 30-foot spacing, a lot of times GLD will project that we don't have that much of an issue or much difference on maximum entering water temperature. So it all depends on the conductivity and how quickly your load spikes. So that's really important to have a good 8760 annual hourly load to do your design work with. Pre-construction. Now we're getting into the nitty-gritty right before you start up your job. This is where you really want to make your contacts with all of the people that are involved with installing your ground loop. And when I do a pre-construction meeting, I want some key people there, not just the looping contractor. I want the mechanical contractor and the general contractor there. The reason being is all these guys are going to have overlapping duties, and they have to be on the same page. And getting them to communicate early on makes a big difference, I've found. Also, it allows people to get questions out. Another big thing that we find is I've had jobs where no one knew who was going to do the purging and adding the antifreeze to a system. So this gets a chance for everyone to talk face to face, and I found everyone stays a lot more civil if they've got to meet each other personally. I'll also spring a progress tracking sheet on them at this time. And this is an example. This is for 180 hole field that's about to go in Kansas City for a new IKEA store. And what this does, they're going to fill this out, for example, 10 feet. And the U-bin, we hope, gets to 605. And as you complete the sheet, the way I've got it set up, it immediately calculates at the bottom percentage drilled and completed to date. So it's kind of a handy little tracking tool. The driller, if he's, it's also, if he puts in whatever, it's also good for him to track his consumption of expendables such as grout and silica, and other items that I think are key to tracking. It also does something else. If the driller's filling out the test data that he's flow tested the system and he's pressure tested it, and the time on the pressure test, he's making a statement that he's been responsible and done that. So if there's ever an issue later, you know, he's saying, well, I tested it, so I'm responsible. So it's kind of a handy thing to use for a lot of perspective here. Finally, during your pre-construction meeting, it's a chance for everyone to exchange numbers, names, and who does what. So if you do have an issue, people know how to communicate. And I found that so many jobs go without a pre-construction meeting and no one knows who's doing what, and it's always a zoo when no one knows who's responsible for what. And this is how a lot of jobs get cross-threaded and actually get very problematic. So during installation, what do you want to look for? If you're the designer, you need to be out there a couple times to look at some key things. For one, are the U-bends getting installed to the design depth? And you can check the footage markings on your pipe to confirm that. Another big deal I have is I cannot tolerate people dragging a ground loop in the mud and getting a bunch of dirt or rocks or gravel in it. We've had a lot of problems with drillers doing that in the past. A lot of them that know that we're going to be involved, they tend to straighten up a lot. Another thing I like to do is I have a list I put together, just a laundry list of things to inspect when I go out on a job. And I hope everyone can see this revolving spreadsheet I've got here. But it's just a laundry list of things to look for when you're out there. Not everything's happening at one time, but it gives you a chance or it's a good reminder list of what you need to be looking for quality control and quality assurance of your loop installation. Also, if you do have thermally enhanced grout spec, we find a lot of times drillers, we've had several jobs recently, the job was nearly done, they hadn't even sent in their first grout sample to be tested. So we get out there with the cattle prod and make sure that on that very first batch in particular, that morning the sample is taken, and that afternoon it's on FedEx to whoever we're having doing the testing, like GeoPro or whatever. So during installation, what other things are you looking for? Well, flow and pressure testing of your loops and header pairs. Again, I like to flow test every individual circuit to a minimum of 9.1 GPM. Why? Because for inch and a quarter pipe, that's the minimum purge rate for air. But that verifies you don't have anything blocking a loop. You may have it all headed up and you think you've got flow, but how do you know you've got flow through every loop? So I like to do a flow test on each individual loop. I don't care if it's 100 whole job. Once a contractor's rigged up to do that with a purge pump, he can do that really quick. The other thing I've seen, if you're out there observing it, and all of a sudden you get a slug of water coming out of the loop that's muddy and dirty, that goes back to quality control of the installation, that someone wasn't watching their pipe and they've got it contaminated. So that might give you some recourse to get them to do it right. So other things to look for, proper headering depth, that sort of thing. Finally, when this thing gets towards the end, we want proper documentation. We want to see all the warranties and whatnot. Of course, a lot of this was in your submittal set, but your as-builts, you've got to make sure they're compliant, not only with your design documents, but if you have to adjust them for whatever reason, that has to be updated. And of course, compliance with any regulatory agencies involved. If any of you guys are from California, you'll know what regulatory means. Here's just a shot of a pressure test in progress. And to make a point about contamination in ground loops, on the upper left-hand photo, that's from an actual system, header piping in North Dakota. And the driller was claiming that, oh, we can purge all that out. That's not a problem. And I had a little bit of heartburn with that statement. And on the lower right, the driller's pet lab didn't like my design, decided to to redesign by pulling up the pin flag. So anyways, site visits can be enlightening. And that's all I've got. I've got a few follow-up slides just to make a few points. This is a project where the ground source heat pump system, even including the ground loop, came in at a lower cost than the conventional boiler chiller system. And that's only a 46,000 square foot facility. Have a project, we're actually in phase 2 right now. This is a low-income housing project. Just by proper design, going through the pre-design process with the architect, we dropped from 90 holes to 50 holes and saved quite a bit of money on this thing. Nearly 170,000, a little over $170,000 in installation costs by just proper design evaluation. And then on another project, sometimes for whatever reason we can't drill them, so we go horizontal. That's for a National Guard facility in Delaware. It's a pit loop on steroids. And then on this project, the job was going to die because we were in very ugly, rocky conditions that the drillers were just having all kinds of problems with. And then we find that the client was going to have some big ponds outside of the building. And so we spec'd a surface water heat exchanger. And those are EnviroPlates. And finally, one of the things I just warn you about, software such as GLD, if you've got an imbalanced load, and most of them are by definition, you're often going to get a projection that you're going to overheat the ground loop in so many years. Take that with a grain of salt. The reason being is, in reality, most ground loops are very poor thermal energy batteries. They want to lose heat as soon as you quit rejecting it. So if you've got a normal, whatever normal is, operating cycle, and each peak here represents a 24-hour operating cycle on a large, in fact, this is a large IKEA store, 420,000 square feet. And that red, that's the water going to the loop field. And if you'll notice coming back, this loop is trying to go back to undisturbed temperature conditions as soon as it gets any kind of chance at all. So ground loops don't make good heat reservoirs for long-term storage. So just word to the wise. And that's all I got, guys. Any questions? If anyone's speaking, I can't hear them.
I just had a question. Some of your forms and well, basically your forms, they're pretty well thought out. I was wondering if they would be available on GLD's website for use.
I can share some examples. Yeah, I can forward them on to GLD, and I think we'd be willing to share some of those. Absolutely.
Yeah, because your spreadsheet, I mean, a lot of thought went into that. Of course, a lot of your experience went into that, and right away I can see where that's needed, you know, and I thought it just well done, just nicely done.
Well, I appreciate it. Yeah, we developed a lot of these sheets and check sheets because it solved a problem, and production tracking is very important to everyone from the architect to the loop designer, and it reveals things. I mean, all of a sudden, if a guy's slowing down, you want to know why, you know, that kind of thing. So, no, I think we can I can forward some examples to Jeff, and he can post on the website or share with those that are that are participating.
And one other thing I noticed is when you were showing some examples of good and poor thermal conductivity test reports, I noticed you were using the GRTI examples there.
Yeah, actually, it really you should be able to produce the yeah, that's a GRTI sheets just because they had a nice pretty graph, and but it really doesn't matter. Like GeoCube, they produce a similar graph with power inputs and that sort of thing. A lot of times, and there's a lot of other people out there that have their own. They've either made their own custom data loggers, or they rent a GeoCube or a GRTI unit or whatever. A lot of times, what I'll do is I will ask for the raw data set if I'm the designer or if I'm doing peer review, and I'll put that raw data into my own spreadsheets to do a reality check on that, because if I've got any question on that power input, I need to know. And but beyond that, it's really important before you do the TC test to make sure everyone's got a clean power supply.
Yeah, basically my business, I own a GeoCube, and I use specifically their software, and so that's my business right now. I'm in the process of trying to go into installation through a residential or light commercial to try to enhance my business, because it's hard to stay busy enough just doing PCT tests. But I've been doing. I'm here in the Northeast, and I do a lot of them around the Northeast area. And I've used the GRTI system, and that's how I know that I could pick that up right away, because I used to use their equipment. And
Gotcha.
so I know what's involved with them, and of course now I know what's involved with the GeoCube, and I'm pretty happy with the GeoCube system of doing things. The other thing I have a question is, where do you send your grout to be tested? Do you send it to GRTI, or are there other outfits out there that offer that service?
Oh, plenty. GeoPro will do it. If you're using their grout, they do the testing for free. If you're using if you use someone else's grout, they'll charge, I think, a nominal fee. I don't know what it is, $25 or something. Baroid does the same thing. They test grout.
Okay.
I think there's a bunch of them out there.
Okay. I just haven't had a chance or anybody asked me about that yet, but I knew that GRTI did it, and then I was thinking that probably most of the grout manufacturers would offer a free service, so I didn't know.
Yeah, no, most of your grout manufacturers offer the testing services either for free or at a nominal charge. It's not a difficult thing. My biggest problem is getting people to get the samples sent in a timely manner.
Yeah, I could see where that could get strung out easily.
Yeah, I'm getting kind of a reputation of being a pain in the ass when drillers see me coming.
So what areas do you concentrate in when you're out there in the field?
Everything from where they've got the pipe stage to how they're treating the pipe before they install it. Okay. And I continue on making site visits until it's headed up in the mechanical room and pressure tested.
Okay. Now, do you operate throughout the U.S., or do you have specific areas that you cover?
Actually, for example, I've got projects right now. I'm based in Denver, but I work all over the U.S., and I've got projects I've done in Europe and New Zealand. So it's
okay.
I'll admit it, I'm a slut. Someone pays me, I'll go there.
Well, that's kind of the way I am with the TCT test. I mean, I offer a real quality report, you know, and when I do it, I'm very finicky when I do the tests.
Yeah,
And, but it's basically, you know, if somebody wants a test, I'll try my darndest to price it so I can get the job, you know.
yeah, we just don't do testing. Yeah, usually when, like, I've got a job in California right now, I'm just doing the design or the peer review. I don't do the actual testing necessarily on a lot of these jobs, but we work with folks like yourselves that do the testing. And that's the point I'm trying to make with this webinar is if you're the person designing this loop field, you need to be talking with the driller. You need to be talking with the guy doing the TC testing, et cetera, et cetera. You don't want to leave this stuff to the general contractor. You want to be in direct communication with everyone that's going to have an impact on your final design of your loop.
Sure. First, whenever I'm doing them, it's always they want the report yesterday.
Of course.
When I get involved.
Absolutely.
Yeah, this one I'm doing here right now, I'm doing 2, and they forgot to call me. So let me know it was ready.
Understood.
So I'm rushing to get these 2 wells done for them right now. So. Well, anyways, I thought your presentation was nicely done. You had some real good support data, and of course, you obviously have the experience necessary to put on a presentation like this. But you know, it's nice to be able to talk to people and get some information from people with that experience.
That's appreciated.
What's that? Yeah, I think I did my time card already.
Terry, has your effort caused the building design?
I thought I did mine.
I'm sorry?
When you've gone through the early communication process with your customer and the architects and things like that, have you ever been in early enough where your design efforts on the loop have caused a building to actually change design?
Yes. In fact, this one right here, this was phase 1, and we got in early enough because of this. We were at 90 holes. We went back with the engineer, and this building was so tight. They were building it very well. This part up here, this phase 1, that's a 3-story, 4-story, I can't remember what, 3-story low-income housing facility. Anyways, we noted that their cooling load was extremely heavy, and they were doing everything they could to minimize outside air impact. What we found was by running a load calculation with lower efficiency windows and slightly lower efficiency wall insulation, we actually balanced the load out, and that allowed us to drop from 90 holes to 50 holes by 400 foot, and it lowered the first cost on the building construction because they were able to go to a less expensive window glass. So yeah, we have proven that time and time again that if the loop design team is involved early on, you find things that can really mean a huge difference on not just your installation but your operating costs. Absolutely.
Thanks.
Anyone else?
Can you hear me?
Yeah, is this Dan?
Yeah, I have a general question. So, of all the things you learned over the years, if someone could have one takeaway from this presentation that would help them, with their quality assurance in the geothermal process, what would be the most important message you'd want to share?
I think would be at the first part of the project that you want to understand what you're dealing with on the job site, knowing where you can and cannot go with the loop, and before you start even working, really working up your loop calculations, understanding your contractor assets and what input they can give you. Like, do you have an ugly layer at, say, 300 foot that you want to avoid? A lot of that stuff can go a long way and save a lot of heartburn later on. In fact, that can save you the entire construction and design process a lot of wasted effort early on by being aware of those things. We find that a lot of jobs people do go off and make assumptions, and then it's a lot of drama midway through when they find they've got these other issues to deal with. So know your site, know your building, know your objectives, and know what you've got to deal with as far as your contractor assets.
Okay, thank you.
Mm-hmm.
Well, thank you, Eric. And we'll get a recording of this posted if there's any part of it that you want to be able to go over again. And thank you, everyone, for attending.
Guys, I do appreciate it. But I always like doing these things. So if anyone needs to get a hold of me, go to our website. It's got my my email address and all that good stuff, and be more than happy to help anyone out.
Thanks, sir. That was a really important and valuable presentation, and we're going to have this up on the web. So, and then after it's up there, we'll send emails out to a lot of people so they'll be able to watch it later.
Very good.
Why don't you share your email address at the end here?
Sure. It's Loopman, Loopman, at majorgeothermal.com. Loopman at majorgeothermal.com.
Great. Thanks.
Thank you.